recording started. Alright, so what shape is this? Parallelogram has two pairs of parallel lines. Do we have two pairs of parallel lines?
No.
No, we only have one pair. Okay, so it's not a parallelogram.
Quadrilateral.
It is a quadrilateral. What kind of quadrilateral is it? It's turned on its side, which is messing y'all up.
Oh, it's trapezoid.
It is a trapezoid. Okay? A trapezoid has one pair of parallel lines, and those are the bases. So if we're looking at this, this is a base, and this is a base. Okay? So where is the height of this parallelogram?
15.
Yeah, this is the height right here, and this is one of the bases, and this is the other base. And that line is the height. It's laying on its side. Okay? So does that help unstick some of you that were stuck? Do we remember the formula for area of a trapezoid? Anybody? Okay, you need to write this down. 1/2 times the height times the sum of the two bases. You need to write that down. You're going to need that on the benchmark next Tuesday. All right, so we have 1/2. You told me the height was 15. We figured out one of the bases was also 15, and the other base is 7. Okay, so we got 1/2 times 15 times, let's see, 15 and 7 is 22. Did I do that right? Alright, so half of 22 is 11. So now we have 11 times 15. So 10 times 15 is 150. And then add another 15 to it. 165 meters squared. All right, questions? So the thing that threw you is it was sitting on its side, okay? You were right, it's a quadrilateral, but we needed to be more specific to be able to find the area of it. All right, questions you have for me? Okay. So you just watched the video on interpreting graphs of proportional relationships. Let's read stories from the graphs of proportional relationships. Come on. So today's goals. First one, I understand the information given by graphs of proportional relationships that are made up of points or a line. Okay, so we did one. You did one that was a line, and then you did one that they talked about it being points, that it should have been points. Okay. All right. I can find the constant of proportionality from a graph. Okay, you should have gotten that out of the video. And the last one is I can draw the graph of a proportional relationship given a single point on the graph other than the origin. All right, so let's look at this graph. We had seagulls and the pounds of garbage that they ate. Remember that problem? Okay? Is it possible to interpret the meaning of every point on this line? What do you think? Can you tell me about this point right here? Well, what is the x-axis? What's on the x-axis? Can y'all see it? What's on the x-axis? Seagulls. Can you have 1.5 seagulls?
No.
No. Can you have 2.5 seagulls?
No.
Can you have 10 1/4 seagulls?
No.
No. So we can't interpret every point along this line. We can only interpret this point, this point, this point, this point, because we can only have whole numbers of seagulls, right? All right. Why is it still useful to draw this line even though we can't have half a seagull? Why is it still useful to draw the line? Why do you think? If all I gave you was this point and this point, could you tell me definitely it went through the point of origin? Probably not, maybe. But as soon as we draw this line, can you see where it goes through the point of origin? Can you estimate about how many pounds 3 seagulls ate by looking at it as a line instead of just this point and this point? Could you tell me about how many 3 seagulls ate? Well, it looks like they ate about 7.5 pounds. Because I can follow along the line here, okay? How can drawing the line help us learn more about the situation? Well, like I just said, it helps us find along the other points. It also shows us that it goes through the point of origin, so it solidifies that it is a proportional relationship between the seagulls and the pounds of garbage. Okay? So we can interpret points on a graph and know what they mean. That's one of the big ideas from today's lesson. The y value that goes with the x value of 1 shows us the constant of proportionality, or the k. So what does the red point on this graph mean? What does this point right here mean? This point is 2, 5. What does that mean in terms of this graph?
2 seagulls and 5 pounds of garbage.
Excellent. Does everybody see how Jahan got that? 2 is the x coordinate, and x represents seagulls. So that means 2 seagulls ate 5, and y is pounds of garbage. Okay? What does the point 1, 2.5 represent?
That one seagull, one seagull ate 2.5 pounds of garbage.
Yes, yes. And is this our COP? Is this our constant of proportionality? Go back to point 2 here. The y value that goes with the x value of 1. So does x equal 1 here?
Yes.
Yes. So whatever y is, that is your constant of proportionality. And we've said that in tables. When x is 1, y is your COP, right? So in the graph where x is 1, whatever the value of y is going to be your constant of proportionality. All right? Could we also find it by doing y over x? What's 10 divided by 4? 2.5. Okay? Same thing we've been doing all along. Alright, let's start with the practice problems. I hope you have the PDF out because you're going to have to be drawing some, and I didn't require you to show me the PDF, so I need you to make sure that you are doing it on paper or on the PDF, okay? There is a proportional relationship between the number of months a person has had a streaming movie subscription and the total amount of money they have paid for the subscription. The cost for 6 months is $47.94. The 0.6 comma 47.94 is shown on the graph. So X is 6, and that represents months. So 6 months cost is Y, $47.94. Okay? Now they want to know what is the COP. Okay? So my suggestion would be, first, let's draw the line. That helps us figure out where the COP is at. So because it's proportional, we know it's going through the point of origin, and we are going to draw this line, and I didn't draw it very straight, but you're going to draw the line. So where X is 1, Y value is going to give us the COP. Now it's not easy to tell what it is in this graph. How do we find the COP if we're given an X and a Y? How do we find the COP?
Y over X.
Y over X. So we're going to take $47.94. That's what they paid, and they paid 6 months. And we want to know how much did they pay in 1 month. So does it make sense? We're going to take the total amount and divide it by the number of months.
Yes.
Okay, because we want to find 1 month. And think about what this point right here means. 6 months, $47.94. I need to know how much for 1 month. So if you take out your calculators and you do 47.94 divided by 6, you get,
7.99.
okay, what does that 7.99 mean? That is this point right here. That is 1 comma 7.99. So what is our,
That's how much they paid in 1 month.
right, so what is our constant of proportionality?
7.99.
7.99. What does it mean in this situation?
The amount they paid in 1 month.
They paid $7.99 per month, or for 1 month. Per month means 1 month. Add at least 3 more points to the graph and label them with their coordinates. Okay, so if 1 month is $7.99, how much would 14 months be? What are we going to do to figure out 14 months?
Multiply
By,
7.99.
okay, so do that for me. What do you get? Do y'all not have calculators?
Well, I'm pretty sure we do, but it's just new to you whenever we use them. Well, at least you use the student one.
Alright, let's see. Math is a participation sport. More than,
111.86.
it's money, so how much money is that?
$111.86.
Okay, so I'm going to come here, I'm going to have the point 14, comma, 111.86. That means in 14 months, I would have paid $111.86. So I'm going to come here at 14, and then I'm going to go 111, which looks like this is 110, so it's going to be about right here. If I continue the line, is it going to go through that? Oh, look, it does. So this is 14, comma, 111.86. All right, what month? we gotta do 3 points, so pick another. How many months do you wanna do this time?
7.
All right, 7 months. So we're gonna do the point 7 comma what? Figure out what that is right there. 7 comma,
Months.
7 times how much per month? So that's going to be $55.93. Okay, we need one more point.
20.
20. Okay, so we are going to do 20 comma what?
7.99.
And that will give us 159.8. So we're doing 20. Oh look, we're pretty close. Okay, because I didn't use a straight edge, we're not going to be exact. But do you understand how we figured out those other 3 points? Okay, we used the unit rate, didn't we? All right. Write an equation that represents the relationship between C, the cost, so this is going to be C, which is our Y, and M, the number of months, this is our X. So if we want it in the form of Y equals KX, we are going to use what for Y? What for Y? C equals,
C equals
7.99.
very good. There's your equation. Okay? Questions you have for how we came up with that? All right, who needs more time to write all this down?
I do.
Okay. That question had a lot of parts to it.
Okay, good.
We're good? Anybody else need more time? Anybody have a question on all of that? All right. On to number 2. The graph shows the amount of almonds in grams for different amounts of oats in cups in a granola mix. Label the point 1 comma K on the graph, find the value of K, and explain what it means. All right, so 1 comma K means where does the graph cross when we're at 1 cup of oats? It would be right here. And this is going to be 1 comma. Now how are we going to figure out what that is? Well, it's kind of halfway between, and we don't know exactly. So what we're going to do is we're going to find a point where it crosses exactly in the corner. So it looks like we have, what could we do? Oh, it looks like it crosses right in the corner right here. Okay? So this we can definitely say is 2 comma 50. Do you agree? Okay. If we know this is 2 comma 50, this is going to be 1 comma what? Well, take your Y over X to find out the COT. So 50 is our Y, divided by our X gives us what? 25. So what is our Y? Our constant is going to be 25. So label the point 1 comma K, so this is going to be 1 comma K, and find the value of K. We just did. K is 25. Now what does this point mean? Well, what does X represent?
One cup of oats.
Okay, so 1 cup of oats. And what does Y represent?
Almonds and grams.
Okay, so 1 cup of oats, and we will need 25 grams of almonds. That's what it means in this situation. If I use 1 cup of oats, I have to use 25 grams of almonds to make that granola mix. Okay, questions you have for me? Does everybody see how we figured out what K was? We're still doing Y over X, aren't we? We're just finding a point that we know definitely the Y, the X and the Y. And then we're dividing the Y by the X. And that's giving us our constant. And the constant always occurs at 1 comma, and then the Y coordinate is your constant. Okay, questions? Who needs more time? Okay. I hope you did this on the PDF, because you need to be able to graph when you take the test. All right, onward to question 3. To make a friendship bracelet, some long strings are lined up, then one string is tied in a knot with each of the other strings to create a row of knots. A new string is chosen and knotted with all the other strings to create a second row. This process is repeated until there are enough rows to make a bracelet to fit around your friend's wrist. Are the number of knots proportional to the number of rows? What happens in each row?
One string is tied in a knot.
Okay, so is it going to be proportional? Are we going to have,
Yes.
if we have 10 rows, are we going to have 10 knots?
Yes.
If we have 5 rows, are we going to have 5 knots?
Yes.
Yes, so is it proportional?
Yes.
Yes, because every row has
Same number of knots.
same number of knots. So this is yes, because every row has the same number of knots. All right, who needs more time for that? Who doesn't understand that and would like to ask a clarifying question? Okay. Last problem. What information do you need to know to write an equation relating two quantities that have a proportional relationship? So if I give you 2 quantities that I say are proportional, what do you need to know to write an equation? Well, what does
It would
the,
have to be in y equals kx.
okay, so it needs to be in y equals kx form. So it looks like, what are we gonna need? We're gonna need a COP. Okay, what are these called? What are x and y called?
Variables.
We need variables. We need 2 variables. 2 different variables. Okay, what else do we need?
A table.
Equal sign.
An equal sign. Okay, what operation is between k and x? Adding, subtracting, multiplying, or dividing. Multiplication. So we need to know that when we have 2 variables next to each other, they are multiplied. Okay, anything else we need to know? Do you have any questions from the video? Let's go back to the big ideas. You may want to write these big ideas down. We can interpret points on a graph and know what they mean. How do you feel about that now? We did 2 of them. We did the cost of streaming video per month, and then we did the granola mix. So can you interpret a graph based off of what X and Y represents? Okay. Then the other big idea is the Y value that goes with the X value of 1 shows the COP. So right here, X is 1, so the COP is whatever Y is, and that's 2.5. And the way we discover that is we do Y over X, 10 divided by 4. We find a point that is in the corner of the grid, so we can definitely say this is 4, 10. Or we can say this is definitely 2, 5. So we will take 5 divided by 2, 5 is Y. 5 divided by 2 to give us that 2.5. All right? Questions you have? Do you want to take a screenshot of that so that you understand the big ideas from today's lesson? All right. If you don't have anything for me, we are finished for today, and I will see you tomorrow.
Bye.
Bye. Have a good day.